Now that we are delving into the world of modeling that involves equations, we must get comfortable with the notion of the mathematical world. In this module, we will take some tips that will help us to make math readability easier for us. Specifically, we'll start with certain concepts such as quantification, formalism, and then we'll conclude with some best practices to read mathematical expressions. The famous Shannon, who gave the channel capacity expression, which is C is equal to B log of 1 plus S over N. He said that a model is a representation of an object, a system, or an idea in some form other than the entity itself. It means that before stepping into the realization of a practical system, any effort that you do that tries to mimic that system is a model. Now we start with the concept of quantification. Quantification forms the basis to give us a reason why should we use mathematics to model after all. Quantification is actually the process of counting and measuring. This counting and measuring maps the human sense of observation and experience into numbers. To put in simple words, it presents us with facts which represent the reality, and it forms the basis of science. On a side note, back in old days, an effort was made to define abstract science, which does not make use of quantification. But science cannot be abstract, so as a consequence, that notion did not proceed any further. The next important thing that we need to understand is formalism. As the name implies, formalism means to approach something with formality. When we look of formalism, we understand that it is mathematics that creates a very formal relationship between different entities of a model. So, the mathematical statements are actually formally telling us about the consequence of an operation, a procedure, an algorithm that takes place, and the results are generated according to the relationship between different entities. The relationship of these statements is actually defined as string manipulation. With such backdrop of quantification and formalism, it is the right time that we start getting to know what are the best practices or the tips of the trade to understand mathematical expressions written by somebody else. A. We need to convince ourselves that understanding mathematics is like understanding any other foreign language. Just to give an example, if we look at the Korean language symbols, we would look at them in estrangement because we do not know what these symbols do and how these can be associated with each other. But when we start slowly getting comfortable, we know that after all, Koreans speak and convey their feelings, sentiments to each other using the Korean language. So they use these symbols using some grammar, some articulation rules. So, when we look at mathematics, look at it like a foreign language. B. Learn the formulas that you already understand. I remember that remembering the algebraic expressions by heart was handy while I was doing mathematics related problems and in engineering and science during my master's and PhD. I would give the credit to my teachers who forced me to learn these things by heart. So it is a matter of remembering the most important formula and trying to relate the current mathematical expression that is before you to the formula that you already know. This makes the interpretation relatively easier. See, always learn that the formula is giving you something that you must use under certain conditions. It means that a formula may be valid or may be invalid if you do not pass it the right parameters. So the point that we need to understand from C is that when we are using a formula, we must apply the right context to the formula. D. Always keep a chart of the formula that you need to know. For example, if you look at famous Shom series books, you would recognize that towards the start and end of the book, there is some glossary given about well-known mathematical expressions, about logarithmic values. So if you're really trying to understand mathematical expressions of somebody whom you have not worked with, it is always useful to keep these mathematical handbooks convenient. And lastly, some people look at mathematical expressions in fear and try to make inferences from it, which are quite awkward. But we must understand that people who wrote the mathematical equations are humans after all, and when they make a mathematical equation, they want to imply something from it related to their subject expertise. So sometimes mathematical equations by different authors are written differently, but in reality, they mean the same thing. So try to associate the context and the domain in which you are working with the most appropriate and logical understanding that should be mapped with that equation.